Can you see that?
Yeah.
Okay. So one of the things that we did that I think is very important is when we went through, and you can go back and look at the video that we shared back with the spaceship configuration, where we showed how we made the H3, where we pulled the carbon out of, or disassociated it from.
This is the mystery we are asking for.
I'm sorry?
How did you pull it out?
Well, we disassociated it from the CH3. So the carbon.
I know. Well, this is the trick. We want to know how.
Okay, so the trick of how is we put it in a CO2 container with, just like we're making CO2. Let's just say that this box here, for example, is a CO2. We put a copper plate, a nano-coated copper plate, and a zinc plate over here, and we put this in salt water, and we put our CH3 in the middle of this container.
What do you mean container of the CH3? You mean?
No, this would be.
The liquid itself, you just poured it in?
No, we put it in a glass jar, and we put it in the center, and we hooked it up to the sides so that it sat in the center in the water as the CO2 was being made. And then we covered the top with a glass container so that the fields were sealed in. So as this was making CO2, we were disassociating the carbon and the hydrogen in this glass jar in the center. Is that clear?
Could you annotate that on the whiteboard?
Let's try.
When you share your screen, the top row has the whiteboard option.
Which one is the whiteboard? I see the annotate.
Just hit new share. Whiteboard's on the top row.
Next to your green.
Escape. Yeah, close the annotate right now. There you go.
And which one was the pen?
You have it. Just start drawing.
Okay. All right, so here's our CO2 box. Nano-coated copper. Zinc plate. And we put this, rather than a plastic box, we put it in a glass container. So this is in a glass container. Then we put our container of CH3. Sorry for sloppy handwriting. I'm not an expert at this. So that's hanging in this container. And the water level's like right here. Okay. And we let it sit for about 3 weeks in this container. And then we'll pull it out. And one of the things that we do in addition to it, but it's not necessary for everybody because they don't have the same tools we have. But we add, before we even start, we bubble in HHO into this container of CH3. So we call it a hydrogenated CH3. And I showed pictures before of our hydrogenator, if you will. But if you don't have one of those, don't think that you can't do it, because this I think will also get you to to where you can make the hydrogen gas. So now what you're doing is you're disassociating the carbon from the hydrogen in this container. So you still have carbon in here, and you still have H3 in here, but they're not necessarily linked together. And that's how we make it. Now, what we do when we're making our hydrogen is we'll take this same material, because we also believe that what's in here also is that this isn't necessarily all H3. It's also, because we hydrogenated it with HHO, it also contains H2, some degree of H2, and some degree of H.
How did you make the H2? How do you guess it's a H2 and how do you guess it's a H?
So we put a hydrogenator in there, and the hydrogenator bubbles in H2. In other words, it's like what do you call it? Atomic hydrogen. So what we're doing is we're bubbling in atomic hydrogen into here.
You mean molecular hydrogen? Atomic would be H, right?
I don't know what you call it. It's the same stuff that you use to power to run your cars on water.
Hydrogen gas, basically, right?
Yeah, like a hydrogen gas.
But not the HHO?
I believe it's an HHO, hydrogen gas. That's what I've been told it was.
Would it be possible that once you made the H3 and you now add your H3 to a mixture of water and mixture of, let's say, gas water of CO2, and creating again between the two plates, create a condition that you produce hydrogen, and in conjunction with a carbon you can produce deuterium, where let me write it, I explain. There is a possibility that if you take this hydrogen, where am I not being able to do? What to do? No, it's here. Okay, if you take this hydrogen here, this H3 here, and take it to another box where you have a copper and zinc, and sorry, if I take it here and put it back in another composition of salt, different salt than this salt, different composition, and you allow H3, which you added at the bottom, to interact with a new copper, which this copper, if you seal the top, it needs carbon, that if you close the top, will allow this extra carbon which is in there, and you have a H3 which you have there, to this time extract additional what do you call oxygen from the atmosphere without a cap, and then you will get a H2O and CO2, and what is left over will be additional hydrogen, which should be a different color material inside. using a pure water, and or a salt water which is different density than the outside. You still get your CO2 from the oxygen which is getting pulled from the water to create the CO2 in conjunction with the carbon. And at that point, whatever is coming as an amino acid which is different than outside allows you to create a water. And then you should get a pure hydrogen.
Okay.
This CO2, it's because it's all plasmatic. You don't go into the matter state, then allows you to create what you call H2O plus high. The only way you can see it is very, very slow is this marking of the water to see if the water level rises. This needs a special understanding of it, because when you connect your plates, you got to make sure you have a what I call resistive load, and then or you can, it works usually with resistive load. Just a piece of copper wire connecting the two, but not of the same line. You never, when you produce material, you never connect this to this. Anybody who does this, you will find out you actually produce what you call different product, and it's not a CO2. And the production of the you might see pure hydrogen at the bottom, which this conversion is very rapid. You might see a change of color, and you see the color changes are very, very, very rapid in this process. When you connect the two wires, two plates with one wire, you are not using what you call use a chemical reaction, even though it looks exactly the same. But what it looks like when you do a direct connection, most of you'll find out you might get two types of ganses separation. But when you create a separation, because now it has to go through what you call it, interface of the wire, then you create a different environment. There is something which is very interesting, a number of points you have to remember, maybe over years of doing these kind of nano making and gas making has slipped your mind, is that the reason we use salt is not only because of the planetary condition, but salt has a very typical common denominator with, if you look at it, can lead to or can lead to near enough going towards chloric acid. Those of you who find mixture of gases in it, it means you most probably have connected directly. You gone into the battery operation. And, you go into the battery operation. Where here, you go through salt condition. This is what life on this planet depends on. And if you understand this process, you can use the salt to literally release yourself with a lot of things and create yourself a lot of whatever you need. It's two different processes. One is gravitational process, one is magnetical process. NaOH is a gravitational process, where what we call NaCl, or we're going towards a chloric acid, is magnetical, because you release a lot of energy. And if we understand this process, we can literally use it to our advantage to create condition of H2, H and H3. None of you plays with this. I've seen one or two people very early stages played with this and they left it because they couldn't understand. So if you change your salinity and you feed in H3, or bring what H3 you think you produced into a new environment, now you can decide on the salinity or alkalineness, or if you connect the lines to be acid condition, then you go through matter state. Then if you go to the sodium, you go through the plasma state, or what we call cycle of life. This is the difference in the whole understanding and the work of what you see